All right, in this video, we're going to be talking about doing some triangle proofs on the coordinate grid. So general tips and tricks, make sure that you are using the grid even if the question says it's optional. It should really never be optional for you. That should be the first thing that you are doing. And make sure that your work is organized, it's nice and clear exactly where everything is. And then you also want to make sure that you have a nice, strong concluding statement that ties all of your work together. So recall some of these triangle definitions that we've dealt with a little bit. We have equilateral triangle, isosceles triangle, scalene triangle, and right triangle. Now, for equilateral triangle, we have 3 congruent sides and 3 congruent angles, all of which are 60 degrees. For an isosceles triangle, we have 2 congruent sides and 2 congruent angles. Scalene triangle is 0 congruent sides and 0 congruent angles. And then a right triangle, it could be a mix. It could be a right isosceles triangle or a right scalene triangle. But the right aspect of it means that we have a 90-degree angle that is present, which further means that we have a pair of perpendicular sides. So we're going to work on proving all of these different types of triangles. And how we're going to prove it is, if we want to prove something like equilateral, isosceles, or scalene, we're going to be focused on the number of congruent sides, or the lack of, depending on which triangle you're working with. But to do that, right, if we want to show that it's an equilateral triangle, we're going to have to show that there are 3 congruent sides. If we want to show that it's isosceles, we're going to have to show that there are 2 congruent sides. And if it's scalene, we're going to have to show that there are no congruent sides, right? So to show the congruence of sides, or to show that sides are not congruent, whichever way you're trying to go with that, you need to use the distance formula or the Pythagorean theorem. So remember, the distance formula and the Pythagorean theorem give us lengths of sides. So we need to know the lengths of the sides to figure out whether or not they're congruent. And then for right triangle, the aspect, or the only aspect actually right now that we can focus on, is the presence of that 90-degree angle, which means we need to have presence of perpendicular sides. So remember, in order to prove or show whether lines are parallel or perpendicular, we need to use the slope formula there. So remember, if slopes, and you guys can write this down, I don't think it's in your note sheet, but if slopes are equal, your lines are parallel. If slopes are negative reciprocals, your lines are perpendicular. Now, this is also in your coordinate proof guide. You guys will have access to this as well. So let's just get right into an example. So we have the points M, N, and O form a triangle, and what we are going to try to prove is that the triangle is isosceles. So first things first, I like to circle or box the thing we're trying to prove, and I'll just write what I know. So I know we want to show 2 congruent sides. So let's go ahead and plot this. We have 4, -2, which is going to be M. We have -4, -2, which is going to be N. And then we have 0, -8, which is going to be our O. Be very careful when you're connecting these lines too. So for isosceles, I want 2 congruent sides. I'm just going to find the distance of all 3 anyway. So I'm going to start by NM. Find the length of NM, and the good thing about this is that it is perfectly horizontal. So if your lines are perfectly horizontal, you don't even have to do any work. All you need to do is count the boxes. And you can also do this if your segment is fully vertical as well. So to count, I usually like to do this to ensure that I'm correct. So 1, 2, 3, 4, 5, 6, 7, 8. Go very slow there. So NM is just 8, and we get that just by counting, right? Now, we need the length of NO as well. So again, to find the length of a segment, you can use either distance formula or Pythagorean theorem. So what I'm going to do is, for NO, I'm going to use Pythagorean theorem. For MO, I'll use the distance formula, just so that you guys can see both in action. But you guys can choose whichever ones you want to use. Whichever method you're more comfortable with, then so be it. So for NO is right here. So we got to create our right triangle. So I'm going to go down from point N, and I'm going to stop right here, and then I'm going to go from point O, and I'm going to connect those 2. And now we got to count our boxes. So to find this length right here, I'll emphasize where my points are too. And I use these little loop-looking things to help me count. 1, 2, 3, 4, 5, 6. Then 1, 2, 3, 4. Cool. Now we have a right triangle. Our right triangle, we have side lengths of 6 and 4, and we are going to look for our hypotenuse. So we have a squared plus b squared equals c squared. And again, this is the Pythagorean theorem method. and we have 6 squared plus 4 squared equals c squared. So we get 36 plus 16 equals c squared. We'll get 52 equals c squared. So the length of NO is radical 52. So radical 52 equals NO. And I'll fill that in my diagram too. Radical 52. Perfect. Now, we also need the length of side MO. So let's do that in this orangey looking color. Or maybe we'll pick something a little bit different. Let's do like a purple. So, or pink, whatever. So MO, and this is what we're going to use the distance formula. So when you're doing your distance formula, you want to make sure you write your points out. So point M is 4, -2. Point O is 0, -8. And then we label x1, y1, x2, y2, and then we got to write our distance formula. Now, this is how I recommend writing it because people always forget, is it plus, is it minus? So I'll start just by putting my parentheses in, and I know those parentheses are getting squared. And then I just write the signs. It's minus, plus, minus. And then we have x2 minus x1 squared, y2 minus y1 squared. And then we're going to go ahead and make our substitution. So our x2 right now, I'm going to keep it in the parentheses. Our x2 is 0, and our x1, so 0 minus our x1, which is just 4. We're squaring that. And then our y2 is -8 minus our y1, where now our y1 is -2. And we're squaring all of that. So let's go ahead and simplify the parentheses before we square anything. So 0 minus 4 is -4, and we're going to square that. And then -8 minus -2 is going to become -8 plus 2. And we're going to simplify again. I'm fully simplifying before I square just to avoid any mistakes. So we still have -4 squared. This is going to become -6 squared. Now, when you're squaring something, it's the equivalent of multiplying it by itself. So -4 squared would actually separate into -4 times -4, right? And when you are multiplying a negative times a negative, your result should always be positive. So double check that. Some people, they do -4 squared and they write -16. But the concept of squaring something, if you're multiplying a negative by a negative, it should never be negative. You have to make it positive. So just be very mindful of that because it will affect your final answer. But we have radical, -4 squared is going to be positive 16. And then -6 squared is going to be 36. And then if we simplify that, we will get, again, radical 52. And I will go ahead and label that on our diagram. And now what I see that those two distances are the same. So I'm going to even go the extra step of marking that congruence on my diagram as well. Now, we have enough. I can see now, after I've labeled all of our findings, that this triangle is isosceles, but now we need a concluding statement. So triangle MNO is isosceles because it has two congruent sides. All done. And again, you can choose whether you use Pythagorean theorem or the distance formula, but if you're making your right triangle for Pythagorean theorem and you are not 100% confident that it is a correct right triangle, then you could always rely on the distance formula to get you the right answer. All right, now the second type of example is proving a right triangle, right? And remember, to prove a right triangle, that means that we need a 90-degree angle, right? So we need 90-degree angle, which means we need perpendicular sides. And remember, if we need sides to be perpendicular, that's when we are using our slope formula. Okay, so let's plot. We got 7, -1. We got 8, -8. And we have 1, -9. So we have I, J, and K. Okay, so you can when you plot it, you can usually tell the sides that you're going to need the slope of. Because you could see the right angle is going to be around right here, around point J. So I know I need the slope of IJ, and I know I need the slope of KJ as well. Now there are two different methods of finding slope also. If you have your graph done, you can just use rise over run if you wanted to. So if you wanted the slope of IJ, let's do this graphically just by doing rise over run. And again, I'm showing you both methods, and you can choose which one you want to do. We have rise over run. So to go from I to j, we are going down 1, 2, 3, 4, 5, 6, 7. We're going down 7, and we are running 1. So -7 over 1 is the slope for ij. Then we also need the slope of kj. Now, let's use the formula for this one. And here we're rewriting our points. So k is 1, -9, and j is 8, -8. We get x1, y1, x2, y2, and we are using our slope formula. y2 minus y1 over x2 minus x1, and then we will substitute. So our y2 is -8 minus our y1, which is -9, over, and then we have x2, which is 8, minus our x1, which is just 1. So when we do this, the -8, this double negative has to become a positive. So -8 plus 9 over 8 minus 1. That gives us m equals -1 over 7. And now that we have both of our slopes, we'll label it. So the slope of ij is -7 over 1. The slope of kj is +1. Oh, sorry, that's positive. -8 plus 9. +1 over 7. +1 over 7. Okay. So when you compare those two slopes, you're asking yourself, are they negative reciprocals of one another? And remember, for negative reciprocal, like I'll start with a slope. Let's start with this one, right? What is the negative reciprocal of 1 over 7? Well, you have to flip that fraction, so it would be 7 over 1, and then you need to change the sign. So it would be -7 over 1. And it turns out that these two are negative reciprocals of each other, which means that I would write here, I would make little arrows, and I would say, hey, slopes are neg reciprocals. So ij is perpendicular to kj. Okay? Now we need a concluding statement. So our concluding statement has to mention the words right triangle, right? So triangle IJK is a right triangle because IJ is perpendicular to KJ, and whenever you're mentioning something like parallel or perpendicular in your concluding statement, I like to cover my tracks and I'll write in parentheses negative reciprocal slopes and then I'll say so angle J is a right angle. And if you want to cover your tracks even extra, I would say a triangle with one right angle is right. Or you can write is a right triangle. So again, your concluding statement is like the finishing touch of your proof. So I would be as specific as possible. I would not leave any room for error there, because if you have all this magnificent work, but your concluding statement is missing something, you weren't specific enough, like you don't want to lose points for that. All right, wonderful. So just know that if you're trying to prove equilateral, scalene, or isosceles, you need to use your distance formula. If you're trying to prove that it's a right triangle, you need slope formula. And there could be a combination. Maybe you need to prove isosceles right triangle or scalene right triangle, and that's just going to be a combination of the two methods.